We've all dreamed of having an AI assistant like Jarvis from Iron Man. Something that doesn't just chat, but actually does things for you. Sends emails, books flights, automates your whole life. But here's the problem. LLMs are actually pretty dumb. Ask ChatGPT to send an email and it just says, I can't do that. Because by default, LLMs don't interact with the real world. The only way we hack around this right now is by manually gluing APIs and tools together. But it's a mess. It's inefficient, it breaks all the time, and it's nowhere near what we need for real AI agents. But now there's a new solution, a new standard called MCP, Model Context Protocol, and it might just be the key to actually making LLMs useful. So in this video, I'm going to break down what MCP is, how it works, and whether it's truly the key to unlocking AI agents, or if it's just another technical standard that may never gain real traction. So, before we get into MCPs, let's take a step back. To really understand why this is such a big deal, we need to ask, why are LLMs so limited in the first place? You see, at their core, large language models like ChatGPT or Claude are just really good at predicting words. That's it. So, imagine you type once upon a and you give it to an AI model. The model will likely complete it with time because that's the most common combination available. But that doesn't mean that the model understands what it's saying. It's not really thinking, reasoning, or making decisions. It's just recognizing patterns. That is it. Now let's say, for example, you ask ChatGPT to send an email to John. It doesn't actually know how to send an email. It can write the email text for you, sure. But it has no ability to interact with Gmail or Outlook because at the end of the day, it's just a text generator. That is it. So the question that arises is that how do we make an LLM to become actually useful? How do we get it to not just generate words, but take real world actions? Right now, the answer is that we attach tools to it. So, for example, I ask an AI assistant, what's the weather like today in Vancouver? The AI doesn't actually know the weather. It can't check it by itself. Instead, it goes to a weather service API, requests that information from that service, gets the latest forecast from it, and then presents that information to you in a presentable manner. So the weather in Vancouver today looks like this: 96% chances of precipitation, rainfall, blah, 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 blah. What's really happening here is that the AI isn't really checking the weather by itself. It's just using this specific tool that does it for them. And this approach works. Alright, so this approach works and it even supports multiple integrations wherein, the AI doesn't really just have access to a weather tool, it can have multiple tools available over here. And according to the prompt that the user has given to the AI agent or assistant, it chooses the appropriate tool from the list of available tools, requests data from that specific tool, and when it gets that data, it presents that data to the user in a presentable manner. Alright. But the problem that arises is that every tool has a very different way of working. Alright, Gmail is very different from Outlook. Google Calendar's API might just be very different from Apple Calendar's API. Nothing is standardized. The second point that comes in is that APIs are messy and unpredictable, with different formats, authentication methods, and rate limits. And when you start combining multiple tools, as I mentioned before, it quickly turns into a nightmare. Why? Because imagine the scenario. Alright, you want to build a personal AI assistant that reads your emails, summarizes the important ones, adds meetings to your calendars, and even books flights for you. To do this, you'd have to manually integrate Gmail, Google Calendar, and airline booking services one by one. And every time these services introduce breaking changes, you'd have to redesign the majority of your workflow, making the entire system very, very fragile and inefficient. And this is exactly the reason why we don't have a real AI assistant like Jarvis yet. And so that's where MCP comes in. So MCP is a new standard introduced by the company Anthropic that solves this mess by creating a universal way for AI models to talk to tools. So instead of every API being its own separate puzzle that the developer needs to figure out, MCP acts like a translator or a middleman, standardizing how AI interacts with these external tools. Alright, a simpler way to understand this would be to take a look at this analogy that I have here. Alright, Imagine you're traveling to different countries, alright? Each country has its own different type of power outlet. For example, India might have this power outlet, USA might have this kind of power outlet, and a European country might just have this kind of a power outlet. Without an adapter, you'd need separate chargers for every country because this specific charger cannot fit into each and every power outlet over here properly. But if you get this universal adapter, you can plug it into any outlet no matter where you are. So MCP is like that adapter, but for AI. It standardizes the way AI connects to these external tools. So instead of building custom integrations for every tool the way that we had to do it before, AI can now use MCP to communicate with all of them in the same way without any additional work. So how does this actually work? Let's break it down. At the top of the stack, you've got your MCP host. This is the application that uses AI to complete tasks. You can think of it as a chat app, a code assistant inside your application, or any AI-driven tool. Inside the MCP host, you'll find one or more MCP clients. These clients handle the actual communication with the outside world, specifically with the MCP servers, where all the external tools live. Now, whether you're connecting to one server or 10, it doesn't really matter, because MCP is built to scale. The connection between hosts, clients, and servers happens over something called the MCP protocol that we've already discussed before. So here's how the flow works in practice. Alright, let's say your AI assistant, which is the MCP host, gets a question like, how many customers do we currently have in our database? To answer that, it needs to use an external tool, maybe a database query function or something. So first, the MCP client inside your host reaches out to the MCP server to ask, hey, what tools do you have available? The MCP server replies with a list of tools it can access. This could be APIs, relational or NoSQL databases, or even local files or scripts. The host then sends the user's original question along with the list of available tools to the AI model that it has access to. This can be any LLM model, so like Claude, ChatGPT, Gemini, anything. The LLM analyzes everything and responds with instructions on which tool to use and how. The MCP client then calls the correct MCP server, which runs the actual operation, whether that's fetching data from an API, querying the database, or executing some local code. The result flows back through the same chain where the MCP server gives out the result of the tool to the MCP client, and then the host gets back into touch with the LLM model and gives it the tool output. The LLM model then formats that tool output into something which is much more readable and has a very natural sounding response to it, and then that certain response is given back to the user. So what's cool here is that this whole setup allows AI agents to dynamically access whatever external tools they need without needing to hard code every integration. It's flexible, scalable, and clean. One of the most interesting things about MCP is that Anthropic, the creators of MCP, are not the ones building the MCP servers. Instead, it's up to the companies that own the services and tools to build those MCP servers. So why would companies spend time and resources building MCP servers in the first place? Well, right now, if a company wants AI models to work with their service, developers have to manually integrate their APIs, and that's a hassle. But with MCP, if a company builds an MCP server, any AI that supports MCP can instantly connect to it with no extra coding required. For example, if Google builds an MCP server for Gmail, AI assistants could instantly manage emails. If a banking platform integrates MCP, AI could help users check balances or make payments. This removes friction and helps companies tap into the growing wave of AI-powered automation. MCP introduces a new standard for AI interactions. But does that mean it's guaranteed to change everything? Well, the potential is clear. It could make AI assistants far more capable. It could simplify AI integration for businesses. It could even lead to new AI-powered applications. But here's the reality. MCP is just a protocol. If you think about it, we've seen similar cases before. HTTPS made web browsing secure, and SMTP standardized email communication. But not every protocol succeeds. Take Google's Wave protocol, for example. It was meant to revolutionize online collaboration by merging email, messaging, and document editing into one seamless experience. However, it was overly complex, lacked a clear user base, and ultimately failed to gain widespread adoption. As a result, it was discontinued. While successful protocols become industry standards by solving real problems and gaining broad adoption, others fade away when they fail to meet user needs or lack industry support. The question is, which category will MCP fall into? Will companies actually adopt it? Because if major players like Google and Microsoft integrate MCP, it could become the default. But if these same companies introduce competing standards, adoption could severely slow down. So, is MCP the missing piece for AI assistants? Or is it just another protocol that might fade into the background? Well, it's too early to say right now. But one thing is clear. AI needs better ways to interact with the world. Whether MCP leads that shift or something else takes its place, that remains to be seen. If you want to understand the bigger picture of AI agents, how they work, what makes them tick, and how they could evolve, check out my next video here.